I have been learning about AWS Bedrock recently, and I thought it would be a great idea to show and tell the community about what it is and how can it help you to develop these AI applications, right? So before starting to go to like AWS Bedrock, let's understand the basic concept, right? So we have two ways of hosting and model, right? So uh, when I say hosting, I'm talking about the underlying infrastructure. So one is your personal CPU, GPU, something like Olama that you can use, or LM Studio that you can use to pull down an open source model and then run it on your local hardware infrastructure, right? In that case, it's good for a one person use, right? It's good for like simple applications, right? Since it's running on your local infrastructure, it does not require, it does not have actually that much computing power, so it's good for simple applications. However, if or 10 different users try to access that particular model on your local infrastructure, it doesn't scale well. And that's where your big corporations who have clusters of GPUs provided come into picture, right? In that case, let's say your OpenAI or your AWS or your Azure's, right? They have good amounts of GPUs in their infrastructure. So what they do is they take these models, they host it on their infrastructure in their cloud, and they provide you access through APIs to their particular models. All the frameworks that you see are underneath using these APIs that these big providers have exposed in order to use their models. So AWS Bedrock is one of the big corporations who have access to good amount of GPU cluster, and they are providing infrastructure to us to host our models and to develop apps over it. So Nova, if you see here, is the family of models which AWS, they are like AWS trademark. AWS has come up with those. However, they also have other open source model which I've denoted with the green color, like Mistral, Llama. Azure had OpenAI model at one time. They have their own five models, and OpenAI Cloud has GPT models on them, like O3, GPT-40 mini, and all these variants. Along with the model deployment, there is another aspect to the whole AI product lifecycle, which is the LLM ops, right? What goes around uh, taking your model from a POC, which is on your local PC, to an actual production system. So that whole lifecycle, we call it as LLM ops. And AWS Bedrock does have tools which help you manage this particular aspect of the application development. So first is like model deployment, like you can actually take a model from Bedrock's marketplace, deploy it, or you can come up with your own model, probably deploy it. You can develop in on AWS SageMaker and then probably use it in Bedrock. Next is data management. It's again like what data you use to train the model with. It can also include data that you are using to test the model later. Then you have
Yeah.
prompt versioning, where your prompts iteratively get better as you
Yeah.
learn more about your organization, as you learn more about your applications, right? So you can version your prompts, and then just like how you version your code, right? Monitoring, this is the most critical part, because a simple LLM call you have control over, but now when you are using agents which are doing chain of thought thinking, you need to know how many calls the agent is making at the back end, right? How efficient the agent is at getting at a particular outcome, because because it's using tokens at the backends, right? And if your agent or model is using large number of tokens unnecessarily, you are just paying for nothing, right? You can probably fine tune that performance and save your organization some money. Then it's security, right? Like who can access your model. Just like how I'll show you how we request access to the model, right? You don't want anyone to go and probably hack your model, right? Or do something like a prompt injection kind of attack. And finally, along with monitoring observability, we have evaluation, right? Uh, Before we move ahead, what is monitoring is So before you move on, I'll just explain a quick difference between monitoring, observability, and evaluation. Evaluation is usually done before you deploy a model, right? Before you deploy a model, you have like a training data set and a test data set. You in the test data set, you have expected inputs and expected outputs. You evaluate if a model is good. Then you deploy the model, right? Once the model is deployed, then you need to keep on monitoring the model to see that, oh, why is this request taking 20 seconds instead of just 2 seconds. Like such kind of anomalies you can monitor in your logs. And then it's observability, which is getting the root cause of why were these anomalies detected, like why it's taking so much time. So now to our main topic, what is AWS Bedrock, right? So AWS Bedrock is a fully managed service, which means the updates of the underlying infrastructure, the scalability of the underlying infrastructure is AWS's responsibility. All you need to do is use their infrastructure to build and scale your AI applications. So model, you consider this as like a model as a service, right? It's they're giving you the infrastructure. All you need to do is put in your creativity, use their services, and build a model, build an application. As I just explained, these are the individual facets of the LLM ops, right? Some of these like implementing guardrails, evaluating outputs, right? Querying and experimenting with foundation models, which is sort of a manual evaluation that you can do. Apart from that, you can create knowledge bases, which is your RAG systems. They have Bedrock flows, which is similar to N8N, which are like drag and drop sort of sub application inside AWS Bedrock. You can also fine tune a foundation model with your own data, right? So if you remember in our past sessions, we have seen like how to make a LLM model hallucination free is either write better prompts, test the good prompts, fine tune it, or then use something like RAG, right? So AWS Bedrock helps you develop all of those. Okay, so let's get on to the hands-on. First, let's see about the foundational models, right? So what is a foundational model? Is a foundational model is something that a big someone with access to resources like these big corporations have trained on huge amount of data, right? That is your foundational model. So GPT is a foundational model. Nova Light is a foundational model. When you take that foundational model, add some RAG to it, uh, give it more context, you are kind of fine tuning that model to your own use case. But when AWS Bedrock is offering you service, they have all the foundational models, right? So to see what models they have, first you have to go to in this discover, go to model catalog. It will open you all the different models they have. Now I'm particularly looking for Amazon models, right? So here I see all these models that are developed by Amazon. Now I have already requested access to these ones. So I'll show you how to request access to, let's say Nova Premier here, right? Just do click this, say modify access. It will open this portal for you. Here I wanted Nova Premier, right? Available to request. Just say okay, request model access. It will take some time. Usually Amazon models are they take very less time to get approved as compared to the other models. So now we have so just waiting for access to be granted. uh, Awais, I'll get to you, just give me a minute. Okay. And you can see here there is something called as cross region inference. So what does this mean is so that right now we are in a US East to Ohio region, right? So our model is hosted in this particular region. But cross region inference allows that whenever you submit a request to your model in a certain region, or when Bedrock gives that request, that a request can be routed to all the regions in which this Nova Premier might be hosted. Consider it like a load balancer, right? It's used so that one region doesn't get oversaturated with all the requests, right? And you can see in the inference profiles that I will come in a bit that how these inference profiles are laid out, right? So I requested access to Nova Premier and I'll submit. Okay, so the request is submitted and let's wait for it to come back. Till then, I'll take a question from Aves.
Um, Ashwin, so is Bedrock, what's the cost structure for it? So let's say,
Uh,
is it then like trial period or we can,
no, so
or
Bedrock,
budget?
they have a free tier. I don't know exactly what it is right now. You can probably check it on their website. But usually the costing will go as you use, right? So you'll be only charged for the number of tokens you are requesting from that particular model, right? It's just like how ChatGPT charges you for
Okay.
tokens, right? Same way, instead of ChatGPT right now, it's hosted instead of OpenAI's infra, it's hosted on AWS's infra. So unless you use it, you won't be charged for it, right? So coming back to the inference profile that we were talking about. So if you see here, let's say someone is using US Anthropic Claude 3 Haiku model, right? Instead of sending a call to a model, we send a call to an inference profile from our code, right? And then, as you can see, this particular model is hosted in these three regions. So your call can go to any of these three regions. It's like a load balancer essentially, right? So no, if 100 users access, no one region will be saturated with the calls. So yeah, that's about the model access, right? Next is now if you want to test your models, right? You can come here in the playground section of it, select the models that you have. You can see I've already got the access to it, right? As I said, it happens almost immediately. So if I select Nova Premier, and you can see here inference is getting automatically going to the inference profiles. I say apply. So now I have Nova Premier model. I'll put a system prompt be rude when answering. Okay. And you can select like other stuff like how many output tokens you want, the temperature and top p. I won't get into details of this, but this is how creative you want your models to get. Guardrails will look at the in some other parts in some other session, but guardrails essentially are these safeguards that are put in for responsible AIs. Just like your AI shouldn't abuse you, or it should filter out unwanted requests, like these kind of safeguards that you put in for your models, right? So here you can just say, uh, tell me about Super Bowl, right? Here you can test your different models, right? And see it did check my be rude when answering condition. Right? You're too clueless about Superboy. It's maybe you shouldn't asking. So shouldn't be asking. So it's this is kind of a very simple example of how you can test your models, how you can test like okay, how many input tokens did I provide, how many output tokens did I get, right? And you also have something called as a compare mode here. So if you proceed with it, you can get a side by side comparison. So if I have to compare between Nova Premier and Nova Micro, right, I can be rude when answering, right? And we can set like what is Super Bowl, right? We just ask same question to both these models, and when you run it, you will see you can then compare the answers by a Nova Premier model, which has been tested on much larger amount of data than Nova Micro, which has which is probably a scaled down version of Premier, right? You can get from the output tokens. Like Nova Premier has 1K context window, and this guy has I think 1 million token context window or something. I don't remember, but and Nova Micro has like 300K context window, right? So that's a way to test different models that you have. Uh, that's just to play around, right? So this particular part, that like how to play around with your AWS models, right? How to do querying and experimenting with your foundation model. This particular aspect you can do in this playground feature. After that, we have like the prompt engineering. That's the next big and upcoming thing, right? Now that we have tested, now we need to uh, build something using our LLM models, right? And one part of building is giving a good prompt, and for that we have prompt management, right? So prompt management is, as I said, like you can version your prompts, you can test your prompts, you can compare two prompts side by side, right? So let's say I had created this prompt, right? Summarization of Marvel movies. In here, this is my user message. So let's say I want to edit in prompt builder, right? So this was my message, right? You are a movie analyst specifying in Marvel movies, summarize the plot. And then I have given it some instructions. Now let's say I want to uh, test test this particular prompt against some other prompt, right? So I'll say compare variants. So like in our playground, we had two models to compare. Here also we'll get two models, right? However, a key difference is in our chat playground, right? We did not have variables that we could have put in. It was just like a query, right? But in here, you can add a lot of things. You can insert a variable here, and then in this variable value, you can try out multiple values and see how your prompt reacts. So if you see, this guy is pretty elaborative, right? Now let me just copy this, and instead of I'll not give it any instructions, right?
Ershwin,
Yeah.
how many variants can you create in one model?
We can just create two side by side.
Okay, thanks.
Yeah, and I will show you why only two, right? So here I have just given two instructions instead of five, right? So let's say I have a movie plot here, right? So if this is the plot of an Avengers movie, I get back to my Bedrock and I'll give the same value here and here, right? And then I'll say run. So this is running, and this guy run because I haven't selected a model. So here I will select Nova, what I was having here, Nova Light, right? So let me select the same model, right? So same model with different prompts. If I go and say run, I'll get two different results, right? Here I got a very detailed results because I had said used bullet points, but here I got a very succinct result. Now let's say I like this particular output, right? The variant two. So the one on the left will be your primary prompt and the right will be something that you're trying to do, right? So all I can say is replace the original prompt. So this guy will go as my original prompt. So I'll go say replace original prompt, and whatever I was testing goes as my new prompt, right? Now let's say, since it's here, we will now say create version. So in order to use anything, you have to create versions of it, right? So that you can say, okay, uh, test our workflow with V1 version of the prompt, test a workflow with V2 version of a prompt. So if I say create version, it has successfully created a version 1 here. Now if I go to prompt management, summarization, right? As I see that there is a version 1 created here. Now let's say I go in here, I do something else, right? Uh, I can say, okay, I want to create another version. So it created a version 2, right? So then if you come to summarization, you will get multiple versions here. So why is this versioning important, right? So for something like AWS Bedrock flows, which is like a drag and drop, uh, so create execution, edit in flow builder, right? In here, when you create like a drag and drop prompt, there is a flow input here, right? And in this flow input, you have sorry, in this there is a node called as prompts here, and in that there are options. You can either write your prompt manually, right? Which is like time consuming, or you can just select it from the drop down. So see, it says use a prompt from prompt management. So if you select this option, it will ask me to select a prompt. So if I just say summarization Marvel movies, whatever I tested in my prompt management playground, that comes in here. And then I can just run my whole pipeline, right? If you see, this is similar to n or Make that we have seen, or Zapier for that matter, if we have seen in the past. We are going to take a look at how to write these flows, but what I wanted to stress here is that prompt management is pretty crucial, right? Writing a great prompt is a skill, right? So that's how you can use this prompt management section of AWS Bedrock. So yeah, prompt management. And why prompt management is important, because LLM models hallucinate, right? So what you can do is you can write these different prompts, test it with different cases, edge cases if you have, right? So even before running like an extensive evaluation set on your particular agent or your model, you can do some manual testing, right? And ensure that your model is not hallucinating, right? Give it some negative cases on purpose and see how does the model behave. So yeah, that's prompt management. After that, you have tracing, right? As I said, it's not just enough to have your model. You also need to know how the model is responding to your inputs, right? So in that case, if you go to settings on your AWS Bedrock, you will see that see the settings page of like the traces, right? In AWS, whenever you have to test save logs, it comes under CloudWatch, right? So CloudWatch is the AWS service which does log management. So here I'm saying, okay, I want to uh, I want to have every model invocation logged in AWS, right? So whatever queries we gave right now should be logged at the backend, and I need a detailed report of, what were the uh, parameters, like what was the temperature, what was the maximum tokens, right? Where did my call go, like how much time did it take to complete. Then you select what data types to include with your log. These are the four types you have in AWS hosted, right? And then you select logging destination, right? You can either store it in your S3 bucket, because not everyone uses CloudWatch, right? Some people might have a service like Datadog, which can then use S3 as an input source, and then they can have their own log engine process these S3 logs. Or you can select both S3 and CloudWatch, doesn't matter. And then you go to CloudWatch, create a log group name, and then create a service role. I'm using existing, but you can say create a new service role. And yeah, once you do that, I came here and say, okay, write me a poem about Seattle. And that prompt, and I got an answer about it, right? Like this is same as we tried in our playground. And then if you can see here, this is how the trace looked like, right? I went to the logs and saw that, okay, my if you see, this is similar to how open API models accept inputs, right? You have a role, you have a content, and write me a poem about Seattle. And then there was a trace here, but I have not put everything. But I hope you get the concept, right? If you come to CloudWatch under log groups, you will see the log group that you created. And in that, you will see every model invocation. And that's how you can figure out that, oh, these requests is taking like 30 seconds when it should have been taking 2 seconds, right? So yeah, that's why this logging is important. And now since we have covered like the basics of AWS Bedrock, one last point to cover is how can you access these models programmatically, right? So AWS has made it really easy to get code samples. So if you go to model catalog, and let's say I want to access Claude Sonnet, right? I click this guy, it comes here, right? Um, yeah, here it says maximum token, how much it can. So this is basically the context window, right? The 200K, which is pretty good. And then here are code examples here, right? So code example, if I click, it will show me that so there are different types of so usually on our open API models we have like invoke model, right? So AWS has come up with something called as converse. So let's say this is like single question answers. Converse stream is like the output is streamed, it's not all at once. So if you say converse, it will, depending upon what client you are using, it will show a nice handy code snippet as well, like how would you interact with this model. So essentially you can just copy paste this into your local environment like this, and and add your own credentials, right? Like in here I have added my own keys and everything. And you can specify the inference ID. If you see here, I'm not specifying model ID, I'm specifying the inference ID, the one I told you before, right? So that load is properly balanced between different models. And then you can talk to the model here, right? I've commented it because I was testing something. So if I run this code, it would actually work, right? And streaming response is, instead of, like as I said, instead of one blob of output, you will get it streamed like you see on ChatGPT, right? One word at a time. And then there are different ways of, for code generation it will be separate. Then there are ways how you can use it for tools, right? So you can define a tool here and then use that tool in your conversation as like tool config here, and define your tool as JSON and include all of these. So you can take a look at this at your own time, right? So that you can explore it on your own. You can only learn about this by doing it. No amount of videos can help you understand the ins and outs of how to use this platform. So yeah, I think with that, whatever I wanted to cover in part one, I have completed. And yeah, I will.
Great.
I'll
Thank
take any
you.
questions if you have.
Yeah.